Hey y'all, what's up? So I am going to be working through our Spectrophotometry Lab. You should have a copy of the lab procedure paper in front of you as we go through this. The only thing I have up from it is a little data table set up, just to kind of make sure you get that set up right and you're doing the right thing. This will kind of go pretty quick, work at the top and go down to the bottom. The first thing that we need to do, or we were asked to do in the thing, is we need to prepare 50 milliliters of 0.5 molar copper sulfate. If you remember what 0.5 molar means, is that we want 0.5 moles of copper sulfate in 1 liter of solution. 1 liter of solution is 1,000 milliliters. We don't want that much, that's wasteful, right? We just want 50 milliliters and that'll be enough to get it done. So we need to calculate how much copper sulfate will we add to 50 milliliters of water to get that concentration. And we're going to use a little process called stoichiometry. So, where are we at? I'm going to start right here, okay? So we want a 0.5 molar solution, which means we want 0.5 moles copper sulfate in 1 liter of solution. But we want to convert this down, right, so we get to grams of copper sulfate. So the first step in this is how many grams are in 1 mole of copper sulfate? Because we want to convert. So 1 mole of CuSO4 is how many grams CuSO4? To do this, we will calculate the molar mass. So if you look at the periodic table, it tells you the molar mass on there. The atomic mass units is molar mass. The molar mass of copper is 64. Molar mass of sulfur is 32. And the molar mass of oxygen is 16. And there are 4 oxygens, so we're going to multiply that 4 times. So if we add all these together, we get 160 grams. So our molar mass of copper sulfate is 160 grams. What this did, this changed our unit. All right, so these cancel out to 1. Our units are now grams per liter. Well, we got the grams, but we don't want liters on the bottom, so we got to convert that as well. So we'll just keep on rolling. So 1 liter is 1,000 mils. So this cancels our liters. Now our unit is grams over milliliters, but we don't want 1,000 milliliters. How many milliliters do we want? We want 50 milliliters. So now the only unit we have left is grams of copper sulfate. So when we work this out, it's going to tell us how many grams of copper sulfate do we need in 50 milliliters of water to get our solution. So if we multiply the top out, 0.5 times 160 times 1 times 50, this is 4,000 grams copper sulfate. 1 times 1 times 1,000 is 1,000, right? If you work this out, you get 4 grams CuSO4. So what we did, what I did, I guess, what you should do if you were here, right, is, can you see that? That is copper sulfate. We added 4 grams of that to 50 milliliters of water to get our 0.5 molar solution, right? We did this in our test tubes. Next step, which is where you see in your data table, you have this. So you would add 5 milliliters of water, 0 mils of copper sulfate, 4 and 1, 3 and 2. So we're just kind of making these dilutions, making these solutions up. So your next step would be to calculate the concentration, right? So if I added, here's my 0.5 molar copper sulfate solution. And in our table, this is how much of the copper sulfate we added. This is how much of the water we added. So every time we ended up with 5 milliliters, right? 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. So our volume of our final solution was always 5 milliliters. So to determine the concentration of this, right, we use a good old familiar formula, right? M1 V1 equals M2 V2, okay? With M1 being our 0.5 molar copper sulfate we always started with, 0.5, molar CuSO4. Our volume 1 would be how much of the copper sulfate we added, right? So how much of this, okay? Now the first one we don't add any, right? It's just straight water. So first one, our concentration is just 0 molar, right? But the second one, we got 4 milliliters of water and 1 milliliter of copper sulfate. So we added 1 mil copper sulfate to this. Whoa, a little off here. There we go. That's good. We're solving for M2. Our volume 2, every one of these, we end up with 5 milliliters of copper sulfate. Right, so we're gonna set this up the same every time. The only thing that's gonna be changing here is the amount of copper sulfate we add. Our total volume is always gonna be 5 because we add in, 3 or 2, 2 and 3, 4 and 1, whatever. We're gonna get 5 at the end. So we're gonna divide by 5 mils. Divide by 5 mils. All right, so 0.5 times 1 divided by 5 is gonna be 0.1 molar. So over here in our table, this one is 0.1 molar. So just continue to work those out in your table and show your calculations for that. Then, now we need to get, so we got our concentration. You gotta solve for that. We got these are already provided for you. Now we need our absorbance. And we're gonna use the spectrophotometer for that. There's this machine here. We have a dial where we can adjust the wavelength. This is where we'll insert our sample, and this is where it'll tell us what we got. So our dial is set to, I don't know if you can see, trying to get it right, about 635, which is the max wavelength for copper sulfate, where it will absorb the most light. So looking over here, we have our cuvettes, and I've added our solutions. So this is 0 molar solution, 0.1, 0.2, 0.3, 0.4, 0.5. I've added them to our cuvettes. They have a rough side, I don't know if you can see that, and a smooth side. We want to touch the rough side because we're going to shoot light through the smooth side, and we don't want to get our fingerprints on it to throw off our readings. So I'm going to take, I don't know how to do this with the cell phone, right? I'm going to take out this thing. This is what we slide it in. I'm going to put our water in there, right, in our cuvette. I'm going to put it in there. This is going to shoot light this way, right? I'm going to close it. What I'm going to do, I'm only going to do this one time. This is blanking it. This is our water. So if you see there, right? We're blanking the sample. Now our transmittance is 100% straight through that water, and our absorbance is 0 because there's no copper sulfate in there. The copper sulfate is not absorbing any light, right? There ain't nothing in there to absorb it. So I'm going to pull that out. All right, so next I'm going to grab the 0.1 molar. I'm gonna load it in here, right? Loaded it in. I'm gonna load it in our sample. And we're going to see what we got. So the absorbance for 0.1 molar is 0.140A, right? So that's gonna go in your absorbance. So we started with 0, right? So at 0 molar copper sulfate, our absorbance was 0. At 0.1 molar copper sulfate, our absorbance was, what did I say? 0.140. So I'm gonna pull that out. I'm gonna go kind of quick. You see where to record it now. So that's 0.1. Got 0.2 loaded up. I'm gonna drop that in there. Bring it in close. 0.30. That's per 0.2. All right, I'll pull this out. Next is going to be 0.3. Drop that in there. Get you in close. 0.41. If you notice the pattern, the more copper sulfate that is being added to this, the higher the absorbance is. Right, it's absorbing more light. All right, this is 0.4. Now we're at 0.584. So our absorbance is going up because the copper sulfate is absorbing more light, and our transmittance You've also noticed we're not recording that, and I'm just loaded 0.5 in here. Our transmittance has been going down because less light is going through. So now we are at, for 0.5 molar, 0.671 absorbance. All right. So pull that out. I'm gonna flip this. I can't flip it around. I don't know how to do it. Thought I could flip this sucker around. Anyway, so just to kind of look, I don't know if you see this. So you got this graph. All right, so we're gonna apply our concentrations on the bottom, which is this. So this goes on our X, 0, 0.1, 0.2, 3, 4, 5. And then we're gonna apply our absorbance, whatever you got for this, over here, right, on our Y-axis. Now, so I don't know how well you can see this. So if we're going 0.1, 0.2, 0.3, then each one of these boxes is worth 25 hundredths. So this first little line up would be like 0.125. The next little line would be 0.15, 0.175.1. Then we got 0.125, 0.15, 0.175, 0.2, 0.225, 0.25, 0.275, 0.3, 0.325, 0.35, 0.375. You get it like that, right? So just kind of show you how to do that. So what you're going to do is you're going to plot these, okay? And it might not give us an exact straight line across, right? Depends on how great we are, which I probably made some mistakes. So you want to do a line of best fit. And just to do this, you want to try to have the same amount of dots on top as you do on the bottom. And that'll give us a close enough for our purposes line of best fit. Then we're going to try to solve the unknown. So over here, we got unknown 103F. Okay. And I'll put a sample of 103F in this cuvette. So at this time, I'm gonna load that sample up, right? Put her in. Now our sample is 0.196. So our unknown sample absorbency is 0.96. So we're gonna plot that on this graph, right? And see where it falls, right? So 0.196 is almost to 0.2, so we'll plot it. Where does it hit that line of best fit? And then we will go down from there to figure out what the concentration is of our unknown sample. That's pretty much it, y'all. At the bottom of the page, that is our checklist for the things you gotta have for your lab write-up and the point values for those. All right, that's it.